everybody, I'm Tall.
And I'm Small.
And today we are doing Khan Academy's MCAT Prep Biomolecules Bioenergetics Questions numero dos. All right, first question. Chemical reactions can be classified according to free energy changes. A chemical reaction has a delta G of negative 686 kilocalories per mole. Is this an endergonic or exergonic reaction? And how would the addition of a catalyst to the delta G change the delta G of this reaction? So first off, if we have a negative delta G, we have a lower free energy in the products than the reactants. Therefore, it's exergonic.
Yeah.
We're losing energy. We're losing free energy. So that eliminates two of the possible answer choices. So now we either have... how would the addition of a catalyst change the delta G of this reaction? Oh, no, it wouldn't. I almost fell into that trap.
Yeah, so we talked about before that delta G, that reaction is a state function. So it just worries about the beginning and the end and not really how we got there.
Right. So catalyst would only change the middle, how we got there, like transition state or activation energy.
Yeah. So actually, an interesting thing is that like paper is like an extremely exergonic, paper combustion, like bursting into flames or whatever, is like an incredibly exergonic reaction. But the activation energy for that happening is so incredibly high that it will never happen in our day-to-day lives.
Wow.
Is that not crazy?
So it's like, so every time we look at paper, it wants to just burst into flames.
Yeah.
Whoa, but it doesn't because the activation energy is too high.
I don't know if combustion always means bursting into flames, but that's what I've been like conditioned to assume. Worst possible outcome.
Yeah, exactly. Okay, and sure enough, that was the answer. Very cool. All right, next question. What can be said about the levels of energy of products and reactants and delta G in cellular respiration? So, what do you think? You're a respiration metabolism person. What are you thinking?
Yeah, the levels of energy of products and reactants. I would say, so let me write it, my GF, my G final minus my G initial. Because I know the overall, I think, is exergonic, then this G initial must be much bigger.
Yeah.
So my GI must be larger.
Okay, that's what I was thinking too. The products would be larger, would be a larger level of energy, of free energy, than the reactants, which would mean that delta G was negative.
Right.
So of our answer choices, we have reactants are water and oxygen. Reactants are water and oxygen have high level. Okay, these are written very poorly. So I'm just going to read through this really quickly like I would on the MCAT. So I see delta G immediately on each of these. We said delta G would be negative.
Yep.
So we can cross out the positive ones. So there's only two left. They said that there's one that says the products have low levels of energy, and one that says that the products have... okay, so they're talking about different... I see how to read this now. Okay, so the reactants are water and oxygen, and they have high levels of energy, and the products are carbon dioxide and glucose and have low levels of energy. That's not right.
Yeah, so this is another one where we have two levels of an ability to cross something out. So just like we mentioned before with the previous one that we had two levels of doing this, one of them is just simply getting the order right.
Mm-hmm. So the other delta G is negative, which we assume is the correct answer at this point.
Yeah.
Says that the reactants are glucose and oxygen. They have high levels of energy. And the products are carbon dioxide and water, and they have low levels of energy. I think that's correct.
I do too.
And...
nice job.
Hey, good work. Okay. Next question. Oh boy. Photurus lucicrescens. Photorus lucicrescens, okay, that wasn't so bad.
Yeah.
Is a bioluminescent Cellular. Good Lord,
Did you
people.
want to say Cleopatra? Because that's what I wanted to say. It's the
I
same
know.
letters.
When I saw it, it looked like Cleopatra.
Okay.
It's like an anagram of Cleopatra. Okay, so we're talking about a bioluminescent thingy. In simple words, this just means the lightning bug. Oh, well, you could have told us that, Khan. Okay, forget everything I just said. The lightning bug is a beetle that can glow in the dark. Is bioluminescence an endergonic or exergonic reaction? What is the delta G of bioluminescence? I wonder if they expect us to know about... They couldn't expect us to know the chemical processes of bioluminescence.
Yeah.
I mean, we happen to be at a school where we have someone whose research is in bioluminescence, so we might have a bit of an advantage there, but not everyone else does this. So let's look at the answer choices. Endergonic reaction with negative delta G, exergonic reaction with positive delta G, exergonic reaction with negative delta G, or endergonic reaction with positive delta G.
So those first two don't make any sense because they're incorrectly coupling the gonic phrase with the negative or positive.
Okay.
So then we would just have to determine, as simple as this is, a mechanism that we don't have any idea about.
So, okay, because lightning bugs only glow sometimes, maybe that means that it doesn't happen spontaneously.
Yeah.
And it's endergonic? That would be my only thought. But light is given off as energy. You have to be losing energy in the reaction.
So I could argue it with to quote Dr. Smith, some hand wavy science.
Yep, hand wavy science.
So endergonic maybe, yeah, because it doesn't do it all the time. It's not spontaneous. Exergonic being that it's almost a form of like thermal energy or some other output of energy that happens.
Yeah, there's like there is actual just energy being released as a result of the reaction, and that's exergonic.
Yeah. So I don't know if like it eats food and then uses this ability to find mates. I probably would have guessed exergonic, but I have no idea.
I would have too. I would have been torn, but I think I would have said exergonic.
Oops.
Ooh, it's not right. Is it endergonic?
Yes.
It is, but we got to see why, because we don't know if our reasoning is particularly right. So endergonic reactions consume energy. Exergonic reactions release energy. Light is a form of energy. Wait, hold on. So before we even move on, exergonic actions release energy. Light is a form of energy. Bioluminescence releases light.
Yeah, that's where I was thinking.
Okay, but let's keep going. So endergonic reactions have a positive delta G, where exergonic reactions have a negative delta G. We know all of this, Sal. Come on. Bioluminescence releases energy in the form of light, but it consumes a greater amount of energy in the form of ATP in the process. Hence, this is an endergonic reaction with a positive delta G. Okay, so, yeah, I mean, we really were torn kind of 50-50 on this.
I think they would have had to have told us about that. I don't think that's something that's common knowledge from science classes.
Yeah, on an MCAT question, this would have been they would have said in the passage that they have to consume a lot of energy in order to make it happen, and then they would have told you about it.
With a bunch of other words that would be hard to pick out that one little phrase that you needed, but yeah.
But yeah, they would have definitely made it more apparent. They wouldn't have expected you to know the biochemistry behind bioluminescence. But okay, yeah, at least their reasoning works, and we came to that conclusion, but we came to two conclusions because they didn't tell us about the actual reaction, what happens. Okay, next question. In human physiology, endergonic and exergonic reactions are often coupled. How does the ATP Adp cycle couple these reactions? Exergonic phosphorylation of ADP, endergonic phosphorylation of molecules by ATP, exergonic hydrolysis of ATP, or endergonic hydrolysis of ADP. Okay, coupling endergonic and exergonic reactions, and we're looking at ATP Adp cycle. So, do you have any insight into what do they mean when they say ATP Adp cycle?
Yeah, it's the same idea in the different pathways of like I always go back to comparing glycolysis and gluconeogenesis. You want to have those intermediates like many intermediates so that you can change directions quickly. And so oftentimes they'll pair something that is incredibly energetically favorable with something that is that requires a lot of energy to happen. So like one step of the pathway puts off a lot of energy and the next step will be able to use it. So the first step of like gluconeogenesis, it requires a lot of energy to happen. Is so much so that you can't just go from pyruvate back to PEP, that phosphoenol pyruvate. We've got to put one step there in between that lets us like step up the energy to get there. We can't just jump quite there.
Okay. So where does this point you when you're looking at these different answers? We have exergonic phosphorylation of ADP. Exergonic, meaning that we're releasing energy in order to phosphorylate ADP. I feel like it'd be the opposite. I feel like you'd need to put energy into it.
Yeah. I don't know. So exergonic hydrolysis of ATP makes sense, to me, but I don't know that it answers what they're asking me.
Yeah. Endergonic, exergonic reaction, exergonic hydrolysis of ATP. Well, I know that happens. So let's read through and see what actually happens.
Yeah.
Exergonic phosphorylation of ADP, I think that's wrong. Endergonic phosphorylation of molecules by ATP. When you phosphorylate a molecule does ATP phosphorylate things?
Yeah, we definitely use that in metabolism. Like the first step of glycolysis would be taking glucose and adding a phosphate.
Oh, yeah.
Yeah, and that is endergonic.
Exergonic hydrolysis of ATP, that seems right.
I might actually say endergonic phosphorylation of molecule by ATP.
Mm-hmm.
It makes me think of some of those step-up reactions that are, part of the way to... Yeah, I don't know. I don't know here.
I like that. I say we check it. 1, 2, 3.
No!
Ooh, wasn't right.
Ugh.
Oh, your initial hypothesis was correct. Exergonic hydrolysis of ATP. Let's look at those hints. Okay, ATP phosphorylation is not a usual chemical reaction. ATP phosphorylation is not a usual chemical reaction. ADP hydrolysis is possible, but it does not drive exergonic reactions.
So maybe they should have said endergonic phosphorylation of molecule by kinase using ATP. Okay.
Yeah, that's what I was thinking, because ATP is like, it's the food for a kinase, but ATP itself doesn't do it.
Yeah.
Yeah, that's kind of funky.
You should have stuck up and told me and put me in my place.
ADP phosphorylation is an endergonic process. ADP phosphorylation, you need to put energy into it to phosphorylate ADP. Okay, that makes sense. Exergonic ATP hydrolysis releases energy to drive endergonic processes. Okay, exergonic ATP hydrolysis releases energy to drive endergonic processes. Yes, absolutely.
Yeah, I was almost thinking that was too simple.
Yeah, it does seem kind of simple.
Yeah.
But sometimes the simple one's the right one, people. All right, next question. ATP cycle refers to a set of reactions that promotes reversible changes of ATP into ADP via endergonic and exergonic reactions. According to our good buddy Le Chatelier, in his principle, what would you expect to occur if ADP levels increased? So the possible answers are decreased levels of ATP, decreased levels of inorganic phosphate, no change in delta G, or increased rate of the hydrolysis reaction. So if we have low levels of ADP, then you would expect the reaction to shift to, you would expect to start hydrolyzing ATP to create more ADP, according to Le Chatelier. Which would mean that the increased rate of hydrolysis reaction would make sense. But they don't say which hydrolysis reaction. Then you have decreased levels of ATP. You would expect that to occur based on the hydrolysis of ATP.
Yeah.
Even though that other answer doesn't specify ATP or ADP. Decreased levels of inorganic phosphate, you'd see the opposite. Because inorganic phosphate would be coupled on the right side of the equation with ADP.
Right. And
then no change in delta G. No, for the entire thing you would see a change, because if we're going from ATP to ADP, that's negative, and then from going from ADP to ATP, that's positive. If they're in equilibrium, then it's 0 as a delta G, overall. But as soon as you start shifting it, you're going to see a delta G start to form for the overall equilibrium. And it would be positive. It would be positive because you'd be trying to get rid of ADP. So if ADP increased, we would. Oh wait, no. We wouldn't see decreased levels of ATP. We would see increased. We'd be increasing ATP. So increased rate of the hydrolysis reaction? Or maybe I was wrong about delta G. All right, I'm going to try it. Oh, no. So it's not increased rate of the hydrolysis reaction. It is, in fact, decreased levels of inorganic phosphate. Okay, well, Le Chatelier, if we think that we literally just have ATP on the left side and we have ADP and inorganic phosphate on the right side, then if we have more ADP, we've got to use up that inorganic phosphate to make new ATP.
Would you like to know what I need to do to be better at MCAT?
Ooh, what?
Be able to read that it says increased and not decreased. I was confused the entire time you were talking, and I could not figure out what was going on, and I got really frustrated with myself, and then I read the question again and was highly embarrassed.
Okay, so yeah, reading the question, I've had this happen to me a lot where you don't see not in the question or something like that. So yes, if ADP levels increased. So yes, we would see decreased levels of inorganic phosphate because that's on the right side of the equation with ADP.
Yeah, and so I think they probably don't suggest going back and changing answers, but if you want to go back and reread like your discrete questions so you don't have to go through a whole passage and make sure you caught all the knots, if you have time at the end, that might be a good idea.
Yeah, you never know when this is going to happen to you. Okay, next question. What would it mean if an antibiotic fails to distort the binding site of bacterial enzymes? Increased activation energy of bacterial chemical reactions, decreased enzymatic activities on bacteria, increased levels of substrate on bacteria, increased bacterial resistance to the antibiotic. So if you distort the binding site of a bacterial enzyme, I think the only thing you can say for sure is that you're decreasing enzymatic activity.
Yeah, but then it says fails to distort the binding site.
Oh my goodness.
Example numero dos, my friends.
Okay, if an antibiotic fails to distort the binding site, we would see, so is it increased activation energy? I don't think so.
Yeah.
Decreased enzymatic activities, we just said that wouldn't happen because the inhibitor is not working, basically. Increased levels of substrate on bacteria. I don't think so.
Yeah, not necessarily.
And then increased bacterial resistance to the antibiotic. I guess that's the definition of it.
Yeah, I would see that those bacteria would still be able to function so they could reproduce in whichever way they do and survive to pass that on.
Yes, they would survive to pass it on. So the ones that, those would be the ones that would make it through. When they say like it kills 99.9% of germs and bacteria, that's the 0.1%.
Yeah, and they have such a quick doubling time that microbes really have the upper hand when it comes to us.
Yes, but you know what? We're smart because we got it right. Take that, bacteria. All right, next question. The symptoms of a certain disease are a result of increased competitive enzymatic inhibition. What kind of chemical manipulations with enzymes, substrate, or products would minimize the symptoms? Decreased levels of product, removal of an allosteric activator, addition of non-competitive inhibitor, or increased levels of substrate. Okay, Small. So I'm a dog and I'm at a prom.
Yeah.
Tell me what I'm looking at right now.
You're competitive. You're viewing competitive inhibition. So the first weird twin is going up and like running and hugging the girl of the couple.
Before the guy gets there.
Yeah, because he's like off getting punched somewhere or something.
So what kind of, let's see, prom manipulations can we do to minimize this from happening? Do we have more clones of her boyfriend come in so they can kick the guy off?
Yeah.
Which would be increased levels of substrate. So when you have a competitive inhibitor, I kind of remember you don't change the Vmax.
Right.
So the only way that you can overcome the effects of that competitive inhibitor is just
Would
have more
be-
substrate.
Yeah, I think that makes sense to me. Decreased level of product doesn't really make any, like, it would drive the reaction forward, but the enzyme would still be doing what it does. Removal of an allosteric activator. Well, if the activator is helping the reaction move forward, then let's not take that away because we're trying to minimize the symptoms.
Yeah.
And then non-competitive inhibitor, I don't want to add that third brother in there and make it my job harder.
Right.
So I would say that makes sense.
And we were right. Awesome. Next question. The electron transport chain is an important chemical reaction of cellular respiration. What would occur if oxygen was not present in the electron transport chain, meaning anaerobic conditions? The anaerobic reaction would be endergonic with magnitude of delta G smaller than in the presence of oxygen. The anaerobic reaction would be exergonic with magnitude of delta G smaller than in the presence of oxygen. The anaerobic reaction would be exergonic with a magnitude of delta G larger than in the presence of oxygen. Or the anaerobic reaction would be endergonic with magnitude of delta G larger than in the presence of oxygen. Okay, so we have oxygen is not present, and we have anaerobic conditions. So normal ETC is exergonic.
Yeah, it produces like something like 32 ATP or something crazy.
So normal is exergonic. Now we are in anaerobic.
When I first read that, my gut reaction is ETC wouldn't happen. So
Yeah, I know.
So I'm kind of at a loss here.
So would the magnitude of delta G be? So first off, are we still exergonic or endergonic? It's gotta be exergonic, right? If it's happening. I mean, it's not going in reverse.
Yeah, I guess. I don't know what would be the electron acceptor at the end if O2 wasn't there.
Okay, so I say we stick with it's exergonic.
But there are some microbes that use sulfur instead, right? So maybe we can substitute, like S2.
So what would that do? Oh, so you're saying that it could still happen because you have sulfur, but
Which acts much the same way that oxygen does.
But possibly the delta G would be changed because of that.
Yeah.
Okay, so I think I'm solid on it's exergonic.
Okay.
And based on what you just said, I would guess delta G might be smaller because
So like slightly less favorable.
Yeah, a little bit less favorable, a little smaller change. It would probably still be a negative delta G, but not quite as negative, meaning like the magnitude is a little bit less than it, or maybe a lot less than it would be with oxygen.
So I'm thinking maybe on that reduction potential chart that S2 would still be at the bottom, but maybe a little bit higher than O2. And I don't even know that bringing in sulfur is what they were leading us to here, but fingers crossed.
Yes, so we are choosing the anaerobic reaction would be exergonic with a magnitude of delta G smaller than in the presence of oxygen.
Yay!
And it was right! We're really working through these bioenergetics questions. See, people, you just think logically about this stuff. You got to do it quick on the MCAT, but you can get through all of this stuff without knowing the actual content. You just you'll draw on your basic science classes. Okay, it also helps that we were both tutors. Okay, why does muscle contraction result in higher body temperature? Is it because ATP hydrolysis has negative delta G? Because ATP phosphorylation has negative delta G, because ATP phosphorylation has positive delta G, or because ATP hydrolysis has positive delta G? You seemed very happy when this question came up. Why is that?
I did because it reminds me of all of my coupling protein favorite mitochondrial examples in biochem on the test because it was always there. And I would go with here. So ATP phosphorylation makes no sense to me.
Right.
So there's that. So then that leaves us with ATP hydrolysis. I think we already talked about that having a negative delta G.
Yeah, it's a favorable process to happen. You get more energy out of it than you have to put in. Even though, as we learned, you always have to put in energy to break that bond.
So that chemical energy is stored, but you have to do something to it to access it. So just like a glass ornament on the edge of a table, or let's use a cup, like a glass mug on the edge of a table, and there's a lot of potential energy there because it's pretty high off the ground, but a cat still has to tap it in order to release that potential energy into kinetic.
Just put a little kitty amount of energy, and then you get a glass shattering amount of energy out of it. And sure enough, we were right.
Woo!
All right, people, last question.
Hemoglobin.
Hemoglobin molecules have 4 oxygen binding sites that reversibly bind with O2 molecules. Loading HMB, hemoglobin, with an oxygen molecule creates a positive feedback mechanism, making it easier to load subsequent oxygen molecules, which we call cooperative binding.
Woo woo.
In oxygen-deprived tissues, one molecule oxygen is released from hemoglobin-rich molecules, favoring the release of the other molecules. That's pretty smart. What role is oxygen playing in these processes? Oxygen is a competitive inhibitor. Oxygen acts like an activator for loading, but an inhibitor for unloading. Oxygen acts like an allosteric activator, or oxygen acts like an enzyme in both processes. I do not think oxygen is being an enzyme here.
I don't know. It says acts like an enzyme in that it decreases the activation energy for the subsequent step to occur.
Whoa, you're right.
So it's a nice metaphor. I don't know that it's the right answer, but it sounded, when you read it out, which is, I wish we could take the MCAT that way. I wish someone could read it to us with nice inflection in their voice and make everything seem pretty simple, but that jumped out to me.
Oh, shucks. You're complimenting me on air. Okay, so oxygen is a competitive inhibitor. That one doesn't make sense. Oxygen acts like an activator for loading. That's right.
Yeah.
But an inhibitor for unloading.
Not true.
No, because as one oxygen gets unloaded, it makes it more favorable for the rest to get unloaded.
But allosteric activator does not necessarily sound like a bad choice.
So what would an allosteric activator mean?
That, this oxygen binds somewhere that is not the active site of an enzyme and occurs something to happen more frequently than it would have without it. So that might actually be the better choice because it's specifically talking about a site here, and that oxygen binding to its own active site would be an allosteric site
to the others.
Yeah, to the others.
Oh. Okay, I like that. And let's check it. Oh, we got it right. Strong work, gang.